This is to help you with the WebAssign that's due today. I'm going to go over numbers 3, 6, 7, and 10 just to talk you through them. In number 3, we're trying to find the center of mass of the system measured from the left edge of the system. So we're going to treat these 3 cubes as 3 masses. We don't know the mass of the cubes, but we know their relative dimensions. So if this cube has a mass of m, then this is 2 times 2 times 2, so this is 8m. 3 times 3 times 3 is 27m. So m1, m2, and m3, we now have something to call their masses. And then we're going to measure their centers from our 0 reference, which is this left end. So our first cube is at half L. So your L will be dependent on what it says here. So half L, the middle of this cube is 2L from the left end. The middle of this cube is 4.5L from the left end. And then we just use the center of mass equation. For number 6, this is really just a kinematics problem. We are given our times in milliseconds, so we have to divide by 1,000 to get seconds. And then you'll use your how far equation and how fast equations to figure out how far and how fast the 2 stones have fallen at the time that's given to you. Once you know their positions and velocities, you'll just use the center of mass equation for position and then use it again for speed with v's instead of x's to find your answers for A and B. Number 7 really isn't as bad as it looks. Basically, when there is a explosion, those are internal forces, and so the center of mass of the system will continue to move as if nothing ever happened. So if this breaks into 2 pieces and one piece falls straight down, the center of mass will continue to move and land exactly where the whole chunk would have landed if it hadn't exploded. So even though no material will land here, the center of mass will end up at exactly where it would have landed without an explosion. So if that's true, and if this splits into 2 equal pieces, and then if we know the center of mass is where the first thing would have landed, one piece will be here, and one piece will be evenly far away on the other side. So if we know the range, call it r, that would have had without an explosion, then half r is where this piece lands, and 1, 2, 3 halves r is where the other piece will land. Finally, for number 10 is a lot like numbers 8 and 9. You're going to set up a center of mass situation, draw your pictures 2 vertically, the way that we did in class. Choose a 0 that's convenient, probably either the center of the boat or the center of the car, and then just carefully draw it out. You do have to take into account the length of the car and the length of the boat. Basically what happens is a lot like the dog one. Basically what happens is as the boat moves to the left, as the car moves to the left, the boat moves to the right at distance x. So when the car gets to the left edge of the boat has moved a distance x away from the dock. So you're going to create a 0 and then have all your measurements based on that for time 1 and time 2. You can email me if you have any questions.